Hello friends, in today's question, so we are going to solve two questions that were asked in the year 2012. And in the first one, a circular wire loop of radius r is placed in the xy plane centered at the origin O. A square loop of side A having two turns is placed at its center at z is equal to square root of 3 times r along the axis of the circular loop as shown in the figure. The plane of the square loop makes an angle of 45 degree with respect to z-axis. If the mutual inductance between the loops is given as mu naught a square 2 raised to the power p by 2 multiplied by r, then the value of p is. So we are given a figure, and in the figure we have a circular loop of radius r and we have a square loop which is of side A, which is placed along z-axis at a distance of square root of 3 times square root of 3 times r, and we have to find out the mutual inductance between these two loops. So in this case, the important thing is that the square loop is placed in such a way that it is making an angle of 45 degree with the z-axis. So first of all, we are going to find out what will be the magnetic field at this particular, you can say, distance, which is given as square root of 3 times r. And for that, we are going to use Biot-Savart's law. So we say, using Biot-Savart's law, so this gives us the magnetic field B will be equal to mu naught I r square divided by 2 r square plus z square whole raised to power 3 by 2. Here z is this distance, r is the radius, and I is the current that is flowing in this loop, and z is given to us as square root of 3 times r. Therefore, we substitute the value, we get our magnetic field B will be equal to mu naught I r square 2 r square plus square root of 3 times r whole square, and this comes as 3 by 2. So we are going to solve it. So we get mu naught I r square divided by 2. Here we have r square plus this comes as 3r square and whole raised to power 2, 3 by 2 rather. So this comes as 4r square, and we can just segregate it, and we can write this as mu naught I r square divided by 2 multiplied by this is our 4r square whole raised to power 3 by 2, and we can further write it as mu naught I r square 2 and square root of 4 will be equal to our 2, then this comes as 2 raised to power 3 multiplied by r square giving us r cube, and this square goes with this cube. So we get that our magnetic field B will be equal to mu naught I upon this comes as 16 times r. So we found out the magnetic field at a distance z from the loop. Now we are going to find out the magnetic flux through the loop. Magnetic flux through the square loop and the square loop, the number of turns are given as 2. So we can write here as number of turns is equal to 2. Therefore, the flux will be equal to 2 times BA, and the loop is making an angle of 45 degree with respect to z axis. So this comes as cos of 45, and the loop is given is having a side A. So therefore, its area, that is our A, will be equal to A square, and we can write it as 2 times B, and area is our A square, and this comes 1 upon square root of 2, that is cos of 45. And we substitute value of magnetic field also. So we get this as our flux is equal to 2 times, here we have mu naught and I upon 16R A square, and this comes square root of 2. So we can just cancel it. This goes by 8, and we get this as is equal to mu naught I A square upon, this comes as 2 raised to power 3 multiplied by 2 raised to power 1 by 2 times R. And thus we get that our flux phi will be equal to mu naught I A square, and this comes as 2 and 7 by 2 times R. So this is a flux associated with the between the, you can say, the square loop as well as the circular loop. Now we can find out the mutual inductance. Mutual inductance, which is our capital M, is equal to flux associated divided by current, which is I, and therefore we can write that our mutual inductance M will be equal to phi upon I. So this comes as mu naught A square divided by 2 7 by 2, and we have R. But we are also given that given mutual inductance is equal to mu naught A square 2 raised to power P by 2 times R. If we make 1:1 comparison, we can say comparing, we get that the value of P is equal to 7. So this was we were supposed to find out what will be the value of P, and this value of P is equal to 7. And we have another question. In the given circuit, the AC source has a omega as 100 radian per second. Considering the inductor and capacitor to be ideal, the correct choices is or are. So in this case, we are given a circuit, and which is having two, you can say, combinations. One combination is of capacitor and resistance. Another combination is of inductor as well as resistance. And we have a AC source of 20 volt, and current I is the current provided by the source. So we have to find out value of the current, and we have to find out the voltage across 100 ohm resistance as well as 50 ohm resistance, and this is a multi-correct, so we are going to choose one by one. So in this case, first of all, we are going to calculate what will be the individual current flowing through this each arm. So let us consider that we have the current I1 is flowing through one arm which is having 50 ohm resistance, or we can say inductor, and current I2 is flowing through the other arm. And if we say Z1 is the impedance of this entire, this is Z1, and for the other part we assume that the impedance is given as Z2. If we can write that impedance Z1 will be equal to XL square plus R square and its square root, and XL will be equal to omega L. Therefore, we can write that our Z1 will be equal to omega L square plus R square and its square root. Omega we know is of 100, inductor is given as, inductance is given as 0.5, and R1 is 50 ohm. So we substitute the values, we get this as 100 multiplied by 0.5 and whole square plus R is also given as 50 whole square square root, and we get this as Z1 will be equal to, this comes 50 square plus 50 square and square root. This gives us that Z1 will be equal to 50 square root of 2 ohms. And we can also find out the phase angle. So you can say phase angle phi1 will be equal to our tangent inverse of XL upon R, which gives us tangent inverse of XL is of 50, R is also 50, so this comes as tangent inverse of 1. So we get the phase angle phi1 is equal to 45 degree. We can also find out the current, which was our I1. So you can say current I1 is equal to V upon Z1, and V was our 20 volt, Z1 was our 50 square root of 2, and I think, okay, total current is given, not individual current. So from here we can draw its phasor. So this will be our I1 at an angle of 45 degree. Similarly, we are going to do for the other part, which is consisting of capacitor as well as resistance. So let us start with Z2. Z2 will be equal to XC square plus R square. XC is our 1 upon omega C whole square plus, sorry, this is R2 square square root. We substitute the value, we get our Z2 is equal to 1 upon 100 into 100 into 10 to the power minus 6 whole square plus 100 square and its square root. So this gives us that our Z2 will be equal to 100 times square root of 2. Similarly, we are going to find out the phase angle phi 2. Phase angle phi 2 will be equal to tangent inverse of xc upon r, which gives us tangent inverse of 100 upon 100, once again giving a phase angle of phi 2 is equal to 45 degree. Now we can find out the current I2. I2 will be equal to V upon Z2. V was our 20, this becomes 100 square root of 2. And once again, we can now complete our phasor. So this was our I1 at angle of 45 degree. And now we have a I2 which is also angle of 45 degree. And we can find out the resultant current. The current I, that is net current, will be equal to vector sum of individual current. So this angle was 45. So therefore, we can say that net current I will be equal to I1 square plus I2 square and its square root. We substitute the value. I1 was our I1 was 20 upon 50 square root of 2. 20 upon 50 square root of 2 whole square. And I2 was our 100 square root of 2 and it square root whole square, square and this. So if we solve this, we can say the current is approximately equal to 0.3 amperes. So the net current in the circuit is 0.3 ampere. So option number A is correct. Option A is correct. Next, we have to find out the respective voltages at 50 ohm as well as 100 ohm resistance. So we can say voltage at 100 ohm V100 will be equal to I1 times R. I1 is about 20 upon 50 times 2, and this is R1, and R1 was our 50, and we get voltage across 100 ohm resistance. 1 second. Voltage across 100 ohm resistance, this has to be 100. Okay, let us, I think I made a mistake here. Yeah, this is 50 ohm resistance. 50, 50, and this also comes as 50. So here 50 goes with 50, and this comes as 20 square root of 2, and this we can write as, let us rationalize it, we can divide and multiply by square root of 2, so this comes as 10 square root of 2, and which will be close to, I think, 10 into 1.414, so which is approximately equal to 14.14 volts. Let me check if the option matches with this one. Yeah, okay, it's given in, so no need to calculate. So the voltage across 50 ohm resistance is our 10 square root of 2, and 50 ohm resistance, it is given as 10 volts, so which is not a correct option. And let us calculate across 100 ohm resistance. So we can say voltage across 100 ohm, we can write this as V100, and this comes as our I2 multiplied by R2, and we have our I2 is 20 upon 100 multiplied by square root of 2, and this is our, this is our 100, and 100 goes with 100, so we are left with 20 square root of 2, and this can be written as square rationalizing it, which gives us that V100 will be equal to, this comes as 10 square root of 2 volts. So voltage across 100 ohm resistance is 10 square root of 2. Yeah, so option number C is also correct. So from here we can say option D is incorrect, and this gives us that option C is correct. C is correct. So these were the two questions which were asked in the year 2012. So these complete the questions. Thank you.